Hello good people, I'm going to look at the balancing of chemical reaction equations. While there are a couple of methods that we could employ, ultimately they all hinge on a couple of guidelines. The first guideline is telling us that we can increase the amount of reactants and products by using the coefficients, but we cannot introduce any new types of reactants and products into the equation. This guideline is also telling us that we should not change the numbers in the subscript, as that changes the identity of the substance and therefore introduces new types of reactants and products. The second guideline is telling us which order to follow when we balance the equations. And generally speaking, the balancing of chemical reaction equations is easier if we balance metals first, followed by any polyatomic ions that might be present, then nonmetals, then hydrogens and oxygens at the very end. Let me bring in the first example. This reaction equation is telling us that molecular hydrogen will react with molecular oxygen to give us water. Currently, this equation is not balanced. While the number of hydrogen atoms is equal on both sides, the number of oxygen atoms is not. There are 2 on the left and only 1 on the right. A common mistake or a pitfall would be to write a 2 in subscript here. However, if I do that, I'm going against guideline number 1. I have changed the number in the subscript. What is more, I have changed the identity of this substance. H2O2 is not water, it is hydrogen peroxide. So we cannot do this. The only numbers that we are allowed to write in are the coefficients, the numbers that go in front of the chemical formulas. Let me get rid of this little 2 and now think about how I could balance this. I want to increase the number of oxygens on the right hand side. The only way I am allowed to do that is by increasing the number of water molecules. Currently I have only 1. I'm going to place a 2 and essentially now I'm saying that I'm generating 2 water molecules. I haven't broken any guidelines. But by writing this 2, the hydrogens are no longer balanced. So I need to go back and fix that. I have 4 hydrogens on the right, but only 2 on the left. I'm going to place a coefficient of 2 in front of the formula for molecular hydrogen. Now there are 4 hydrogens on the left, 4 hydrogens on the right. 2 oxygens on the left, but also 2 oxygens on the right. Everything checks out. Let me bring in another example. Now we have potassium reacting with water to give molecular hydrogen and potassium hydroxide. According to guideline number 2, I should balance the metals first. I have 1 potassium on the left, 1 potassium on the right. Next, I need to balance the hydrogens and the oxygens. According to guideline number 2, I should deal with hydrogens first. Currently, there are 2 hydrogen atoms on the left and 3 hydrogen atoms on the right. This means that I need to increase the amount of hydrogen on the left-hand side. A common pitfall would be to simply add a single hydrogen atom to the left. From a balancing point of view, everything seems to be okay. 3 hydrogens on the left, 3 hydrogens on the right. But by doing this, I'm going against guideline number 1. I cannot introduce new types of reactants and products. I can only increase the amount of reactants and products already present. So let me get rid of this single hydrogen atom. What are my options? Well, I want to increase the amount of hydrogen atoms. The only way to do that on the reactant side is to increase the amount of water present. So I'm going to place a 2 here. Now I have 4 hydrogens on the left-hand side and still 3 hydrogens on the right-hand side. If I place a 2 in front of potassium hydroxide, I will have fixed that. 4 hydrogens on both sides. However, by doing that, I have upset the number of potassium atoms. So now I need to go back and fix that. I have 2 potassiums on the right-hand side and only 1 on the left-hand side. By placing a 2 in front of the potassium, I have fixed the imbalance. And now I can say that I have 2 potassiums on the left, 2 potassiums on the right, 4 hydrogens on the left, 4 hydrogens on the right, and if I look at the oxygens, I have 2 on the left and also 2 on the right. Everything checks out. One of the reasons that we balance oxygens last is that in most cases, by the time we have balanced everything else, the oxygens will have been balanced as well. Let me bring in another reaction equation. Now we have potassium hydroxide reacting with carbonic acid. Yes, we have not spoken about acids before, but those joys will come too. Anyway, we have potassium hydroxide and carbonic acid giving us potassium carbonate and water. What should I balance first? Well, the guideline number 2 is telling me deal with the metals. Currently, I have 2 potassiums on the right-hand side, but only 1 potassium on the left-hand side. By placing a 2, I have fixed that. What should I balance next? Guideline number 2 is telling me to deal with polyatomic ions if they are present. And yes, they are. CO3 stands for carbonate. So now I could say that I have 1 carbonate on the left-hand side and 1 carbonate on the right-hand side. In effect, I am balancing carbon and oxygen at the same time. And as far as carbonates are concerned, yes, they are balanced. Next, I'm going to deal with the hydrogens. Right now, on the product side, I have only 2 hydrogen atoms, whereas on the reactant side, I have 4. 2 from the potassium hydroxide and 2 from carbonic acid. In order to balance the hydrogen atoms, I'm going to place a 2 in front of the water. Now the potassiums, the carbonates and the hydrogens are balanced. What about the oxygens? Yes, I have oxygens within the carbonate, but I have already dealt with those. I have 2 oxygens coming from the 2 water molecules on the product side, and 2 oxygens coming from the 2 potassium hydroxide on the reactant side. So everything is balanced. Let's move on. This chemical reaction equation looks a bit scary. But even though we have not encountered these substances before, we can still balance the equation by following the guidelines. So I'm going to deal with the metals first. In this case, chromium. There are 2 chromium atoms on both sides, so they are already balanced. There are no common polyatomic ions, so I can skip to the non-metals. And yes, there are 3 non-metals, nitrogen, hydrogen and oxygen. But based on guideline number 2, I should leave hydrogens and oxygens at the end. So let me deal with nitrogen first. On the product side, I have 2 nitrogens coming from the molecular nitrogen. On the reactant side, I also have 2 nitrogens. We have NH4 in bracket, the ammonium, but outside of the bracket in the subscript there is a little 2. And it's telling me that everything inside the bracket is being multiplied by 2. This means that I have 2 nitrogens on both sides of the reaction equation. Great! I can move on and deal with hydrogens. On the reactant side, I have 8 hydrogens. 4 times 2 is 8. On the product side, I only have 2. If I multiply the water molecule by 4, I will have 8 hydrogens on the product side as well. And now I need to check what's happening with the oxygens. On the reactant side, there are 7 oxygens from the ammonium dichromate, and on the product side, I have 3 from chromium oxide and 4 from water. 3 plus 4 is 7, therefore oxygens are balanced as well. One more example and then you can take a breather. In this last example, we have lead nitrate reacting with sodium chloride to give lead chloride and sodium nitrate. I'm going to start by balancing the metals first. In this case, I have 2 of them, lead and sodium. Which one should I deal with first? It does not really matter. I tend to do it in alphabetical order. On the reactant side, there is 1 atom of lead, and on the product side, there is also 1 atom of lead. Beautiful, they are balanced. What about sodium? Well, on the product side, there is 1 sodium, and then on the reactant side, there is also 1 sodium. They are also balanced. Are there any common polyatomic ions on both sides of the equation? And the answer is yes. There are nitrates, NO3. On the reactant side, there are 2 nitrates because of the little 2 after the bracket. And on the product side, there is only 1 nitrate. In order to balance the nitrates, I'm going to place a 2 in front of sodium nitrate. By doing this, I have upset the sodiums, so I need to fix them. I have 2 sodiums on the product side, but only 1 sodium on the reactant side. I am going to place a 2 in front of sodium chloride. Currently, lead, sodium and nitrate atoms are balanced. I need to deal with chlorines. How many do I have on each side? Considering that I have 2 sodium chlorides on the reactant side, that means that I have 2 chlorines on the reactant side. How many chlorines are there on the product side? Well, because each lead chloride contains 2 chlorines, I also have 2 chlorines on the product side, so everything checks out. When balancing chemical reaction equations, there is a bit of back and forth. That is part of the process. The main thing to keep in mind is the law of conservation of mass. We can increase the amount of reactants and products, but we cannot introduce any new players to the mix. When balancing the equations, the suggested order is metals, polyatomic ions, non-metals, hydrogens and oxygens. And while you may be tempted to play or change the numbers in the subscript, keep in mind that we cannot do that. In a way, they are a bit like that chocolate ice cream cake behind a display window. You can look, you can even salivate a little bit, but you cannot touch. That is all for now, and I will see you on the flip side.